Thank you. Good morning, everyone, and thank you for joining us for the first System Engineering Forum event for the 2022 fiscal year. To start, we are recording this event, as you just noticed, so please keep that in mind. I'm Alexander Trang, and I am serving as one of the co-chairs for the System Engineering Forum and helping to facilitate the event. With me this morning is Dr. Alejandro Trujillo, who will be transitioning slides and capturing questions throughout the briefing. Before I introduce our presenters, Dr. James Martin and Jodene Sasine, I'd like to provide a couple of housekeeping remarks. Next slide, please. In general, the Systems Engineering Forum, hosted by the Aerospace Corporation's Corporate Chief Engineer's Office, focuses on applying innovative systems engineering principles across the space enterprise, contributing to mission success while advancing the state of the discipline that may be applicable to a wide range of audience members. Next slide, please. Once again, this event is being recorded and will be posted on our YouTube site and a link provided on the SEF archive page. The presenters today ask audience members to use the chat box to ask questions, and the presenters will address them as they are able. If you are asking a more complex question, please also use the chat box to reserve your space, and you'll be given an opportunity to elaborate during the Q&A session. Please keep your devices muted and cameras off. If you are experiencing issues while using Zoom, you can go back to the SEF website to find troubleshooting tips there. They're also being posted within the chat window momentarily afterwards. With that, we can begin today's main events. Next slide, please. Today's theme is architecting enterprise solutions with the idea that higher-level decision-making requires higher-level engineering and integration and the ability to abstract information. Our presenters are Dr. James Martin on enterprise architecture-based portfolio management and Jodene Sasine on agile agile enterprise engineering analytics. Next slide, please. Our first presenter is Dr. James Martin. His specialty is enterprise system engineering with a focus on enterprise architecture, which includes architecting processes, methods, and tools. He is a member of the OMG Revision Task Force for the Unified Architecture Framework and is a primary author of the UAF Guide. Dr. Martin is a fellow member of INCOSE, has a PhD in enterprise architecture, and is a distinguished engineer with the Aerospace Corporation. With that, we'll begin with our first presenter, Dr. James Martin, and we'll introduce Jodene Sasine at the next hour. Thank you. Take it away, James.
Thank you, Alex, for the introduction. So as Alex mentioned, we're talking about architecting enterprise solutions. And when you do portfolio management, typically this is for a set of programs, usually within an enterprise. So the model-based system engineering approach is not often used at the enterprise level, but it is catching on more and more. So I'm going to be presenting some concepts and approaches that we have been using with several of our space enterprise customers across the country. So any enterprise has various drivers of a strategic nature. Usually the enterprise has developed a strategic plan which defines their own goals and objectives for the things that the enterprise would like to achieve, but there's other kinds of drivers that need to be taken into consideration. For example, national priorities such as the national military strategy, national intelligence strategy. There could be civil transportation objectives or initiatives. There may be treaties between countries. There may be agreements between organizations. Of course, there's laws and regulations that you have to comply with. And of course, there's social and cultural expectations, and these are the various kinds of drivers the enterprise must deal with. So given those drivers, they need to identify what are their challenges from a strategic perspective, overarching everything the enterprise does, to particular things inside the enterprise. So there's those two kinds of challenges. And when they identify challenges, they're looking with respect to what are the enterprise missions. In other words, what is the enterprise chartered to do? And what are the initiatives the enterprise currently has in place that may present some challenges to addressing these drivers? So in the end, the enterprise is trying to deploy capabilities that will achieve some effects or results usually outside the enterprise, so they may be increasing shareholder value, increased dividends, providing jobs to the community, various kinds of effects. So these effects come about because the enterprise has operational performers and operation activities that are using these capabilities to achieve those effects. So within the enterprise, we have a portfolio of various kinds of projects, programs, systems, services, and we call that the portfolio. And there's various solution elements that are in those portfolios. So if we have the right portfolio, then we can better address the challenges that we've identified to deal with those drivers. So when we're managing the portfolio, we're trying to maximize effectiveness, but also to minimize cost. Of course, we're not trying to drive cost to zero. We have to spend some money to do important things to achieve our goals and objectives and to address all the drivers. So costs tend to come in two forms: all the resources, human resources, physical resources, facilities resources, and so on, and also the people. The people have a cost involved with them. Effectiveness is at the enterprise level is two components: the capabilities we deliver and the operations that we perform in order to deliver those capabilities to achieve some effect. So before I talk about the approach for applying model-based system engineering and architecting to the enterprise level and managing their portfolio, I need to discuss a few key enterprise concepts to put things in context for what it means to do things at the enterprise level versus down the programs and projects. So systems, as we all know, as all of us system engineers know, we learn the functional analysis approach, where we treat the system like a black box initially. We identify all the expected inputs, and we look at to find all the desired outputs, and then we figure out what does the system have to do. In other words, what are the functions that will transform those inputs into those outputs? Furthermore, we need to look at inputs we don't want to come into the system, and how do we handle inputs that are not desirable, and how do we avoid negative outputs? So that's the very traditional system engineering approach that's been around for 50 or 60 years. But when you apply system engineering concepts at the enterprise level, it's typically not very effective trying to identify the thousands of inputs and thousands of outputs of an enterprise. So instead of an input-output approach, enterprise system engineering takes more of a driver outcome approach. And outcomes is not the same as outputs. Outcomes is basically the results we're trying to achieve or cause to come into effect. And the drivers, as I mentioned before, are the things that drive the enterprise, what motivates the enterprise to do what it does. So given that, system architecture is, if I can make an analogy, is like blueprint for a building. I will hire a building design firm that will draw up some blueprints, maybe an architect, but it could just be a construction firm. And then I, the owner, or the future owner of this house, will work through several versions of the blueprint to make sure we're going to get what we expect, and it's going to cost as much as I can afford, and so on. And it's pretty certain that the house that gets delivered matches the blueprints 100%. In fact, if in your final walkthrough, that's usually where you check in. Oh, we said there's going to be 2 lights in this room, not one. Oh, there need to be a door over here. Oh, the windows need to be over here instead of over there, because they're checking everything against the blueprints. Enterprise architecture, on the other hand, is more like urban planning. You don't have a single blueprint where you're going to get exactly what is on the page. You do have enterprise urban planning, long-term plans. The community or the city puts together, and it's usually a very long-term strategic plan going out 30, 40, 50 years. And this is where they're defining some general guidelines, establishing some rules in terms of codes they have to follow, some zoning restrictions, like what you can build in certain areas. There are certain areas dedicated to commercial, some areas dedicated to residential. Some are set aside as parks and recreations, entertainment, and of course you need some place for transport, for cars and trains and airplanes. So in other words, you need to take care of the transportation of goods across this community. So what the enterprise is doing is looking at the outcomes, the results we want to achieve for our community or our urban area. And the nature of enterprise, it's very complex, and there are many moving parts. There's many complex relationships, and everything is moving over time. And partly because an enterprise is for the most part, more consists of people. In other words, the social aspects than technology. There are some technological aspects, but for the most part, an enterprise is more dominated more by the social and political rather than the technological. So all these things need to be kept in the account when you are managing a portfolio for the enterprise. So if I can draw another analogy, traditional system engineering on a project, which is like the blueprint, you make the blueprint of the thing you're going to build, and it's like the watchmaker. You expect you put these parts together and you will have a timepiece that gives you very correct and accurate time, and is very reliable. So traditional system engineering has all of its methods and tools with the notion of a watchmaker as the way things work. Everything is to be expected, more or less, with some uncertainty, but still, the engineering has some analytical technique that can project toward the future about, if I use this technology, how fast can I go? Can I achieve these performance requirements? On the other hand, enterprise engineering is more like the gardener, where you have to, look ahead several seasons, sometimes multiple years. Sometimes you have to rotate your crop from year to year. So it's more of a long-term venture with a lot of predictions like to make, but the weather doesn't cooperate. The insects don't cooperate, so you have to continually monitor what's going on weather-wise, insect-wise, health of the soil. I may have to fertilize, I may have to remove weeds, and you have to keep repeating it because it's continually changing. So it's a lot of monitoring, and there are many factors that you cannot control as much as you would like, unlike a watchmaker where you're pretty certain what the environment will be and how the watch will be used. So here's a standard enterprise transformation model that's used in the enterprise engineering domain. So taking those drivers of various kinds, demands, competition laws, and so on, and you're trying to achieve certain outcomes in terms of product, services, revenues, and so on. The enterprise has certain states along a timeline where the states are changing over time, and you're trying to use work processes within the enterprise to change the state to always be on a good trajectory to achieve the desired outcomes that you've laid out. And often we define these desired outcomes in terms of strategic plans, project plans, program plans, business plans, and so on. So the goal is in enterprise engineering is taking all these drivers, how do I achieve those outcomes? So your portfolio, you have a current portfolio which consists of various items. I show systems here, but it's more than systems. It could also be buildings, roads, human resources. It could be intellectual property, various kinds of things in your portfolio. And you have some future portfolio that you would like to have. So you might have some resources or assets in your portfolio now that you want to get rid of, and some new asset that you want to acquire. So if we want to do modeling to model the enterprise and model the elements of the portfolio, there's several things in the modeling landscape. Obviously, modeling languages, because you want to have a standard language, provide syntax, notation, and semantics that will give you the basis for building the model of your enterprise. And we often build an architectural model of the enterprise, hence why we called it an enterprise architecture. So there can be standard architecture frameworks that you can use that have standardized viewpoints, view specifications, and provide a standardized domain meta model for the domain you happen to be working in. And if you combine the framework with its views defined and the modeling language with its syntax, notation, semantics, you have a modeling profile. In other words, the profile tells you, here's how to build these views using this particular modeling language. And then you need some sort of modeling workflow that handles all the views in the framework. And you combine the profile and workflow into some sort of modeling methodology. So every organization that is modeling has a methodology, whether they have it documented or not. So the reason we have a methodology is so we can create models. And the reason we create models is so we can create views of the architecture in various timeframes and various situations and various use cases. And typically the views are meant to be shown to human stakeholders. So the views often need to translate the technical aspects of the architecture models into something that will communicate better to the various stakeholders. And so you can judge to make sure the architecture you're shooting for is going to be the right one that maximizes satisfaction stakeholder concerns. And we usually take a number of views and package them up in some sort of architecture description that we can put on our web page, issue to contractors, put it in a contract, deliver it to potential builders and ask them, what would it take to build this? A couple other things in the modeling methodology, modeling patterns and modeling templates. And there's a number of textbooks that talk about modeling patterns, but sometimes even the architecture framework will actually have some modeling patterns in it. But for your organization, you need to decide which patterns are we going to follow, so you can more likely have consistent models across the board that follow the same pattern. And modeling templates, you might say, are partially built models that fill in the blanks of the generic stuff, and then for particular situations, you fill in the template to fill it out. So a modeling template might be 70, 80% a completed model for your particular organization. So the Object Management Group issues several modeling standards. We all know about UML for software, SysML for systems, but the UAF, Unified Architecture Framework, also provides a modeling language within it. And of course, there's the business process modeling language. But the thing I'm going to focus on now for the enterprise architecture-based portfolio management is how do you use the Unified Architecture Framework language to build the models you need to characterize the portfolios, the portfolio you have now and the portfolio you might have in the future, to figure out what's the best portfolio to help achieve our goals and objectives for the enterprise. Of course, the UAF is built upon SysML, so you're actually getting both. So when you flow down your architecture down to the projects, they can easily transition to your SysML models that characterize particular systems. Enterprise modeling, I mentioned the UAF profile, which is actually a modeling language. Prior to the UAF profile, there was the unified profile for DODAF and MODAF. But over time, they added additional frameworks, like, for example, from NATO, for Canadian framework, the UK MODAF, and service-oriented architecture ideas, and so on. And now we are into the third version of the UAF profile. So the UAF is specifically designed for modeling enterprise and missions and system of systems. So it has 230 stereotypes that are defined for the enterprise domain based upon the SysML and UML stereotypes. As I mentioned, taking your enterprise architecture, at some point you need to model your systems, and that's where you would typically use SysML or another language like architecture analysis and design language. At some point you probably will have software where you use UML for that. So the Unified Architecture Framework defines a number of view specifications that are instantiated in the modeling tools. So most of the major modeling tools have a UAF plugin that is conformant with the view specifications in the UAF standard. And these view specifications are organized by a two-dimensional grid where the rows represent the different domains or viewpoints, and the columns represent different model kinds of models, or different aspects of the architecture. So here's the full complement of the 72 views that come with the UAF standard. Now, also with the framework, the standard, in the next version coming out next month, there is now an enterprise architecture guide for UAF. And many of the things I talk about in here as applying this to portfolio management are discussed in the guide. So the UAF language, of course, is how you build your models, and the ontology is the basis for the contents of the views. but the guide is going to give the modelers and the model managers and the architects a bit more information about how you go about building the right models to achieve my understanding of the portfolio of the enterprise. So within the UAF standard is a conceptual schema, and this is explained more in the guide. The major component of the UAF spec is the domain meta model document, but that's a very highly technical document. If you're not a hardcore modeler, I suggest you look in the guide and examine the conceptual schema, because these are the conceptual entities and relationships that engineers, architects, program managers, and so on would have, or would be more likely to understand as far as all the moving parts of the architecture. So when we're building models and views, there's various use cases. You can see various uses for models and various uses for views. As I mentioned, the views are typically designed to be communicate to human stakeholders. And three of the common use cases have to do with portfolio management, particularly informed decision makers, because somebody in the enterprise needs to make a decision about changes to the portfolio. But before you even go to decision makers, you need to validate these future architecture with stakeholders to see how well it addresses their concerns and how well it addresses their mission and business needs. And eventually, you need some funding, some budget, to implement the changes to the portfolio, to changes to the programs and projects. So you can use the architecture views to help justify the budget, the request for the budget, and the plans for implementing the changes to the programs and plans. And of course, you can also use it for basis for requirements definition and for planning or verification and validation. How would you model this enterprise? I mean, when most of our enterprises are not cities or they're not communities, but in many ways, our enterprise we work in is sort of like an urban landscape. So how would you go about this? So my recommendation is to use the UAF language and use the guide that goes with it as the basis for building enterprise architecture models. And we've recently added some new modeling concepts to the front end of the UAF ontology to better handle some of the strategic planning elements, particularly the drivers, challenges, and outcomes that we didn't have previously in the UAF ontology. Why not just use SysML? Well, SysML is designed specifically for modeling systems and doing system engineering. When I say system engineering, I mean system engineering on programs and projects. But what we're talking about here is enterprise system engineering. So as I told you before, the nature of enterprise is different than the nature of systems. Of course, you can say an enterprise is a system, but it's not the kind of system that typically system engineering textbooks will talk about. In other words, they don't often talk about the socio-political aspects of the enterprise as a system. The UF modeling language does provide all that, plus some more things, some specific concepts dealing with capabilities in enterprise, the concept of services, adding in human factors, security, standards, how are projects delivering the resources the enterprise needs, how does the system configuration change over time, and it provides a much better tie-in to requirements tools. That helps you tie the architecture element directly to the requirements, which is sometimes hard to do. It's not impossible, but it's more difficult to do when you're doing SysML. And it has built-in traceability between the variety of views that UF provides. So more on the three sets of views. It provides a new set of ontology, conceptual elements for dealing with security. Some new aspects of modeling personnel, such as roles and responsibility, knowledge and skills, role dependencies, and resources that go beyond just systems, such as technology, natural resources, services, resource services, and things like resource ports and resource interfaces. You have all these 72 views, so the question often comes up of what elements are in my portfolio, and if I know what elements I'm looking for in my portfolio, which of these 72 UAF views are relevant. And that's where the Enterprise Architecture Guide can help you choose which, not only which views to use from the standard, but also what contents, what kind of data do you need to collect to populate those views. So there's also a question of, okay, for all the elements in my portfolio, how much value do they deliver, not necessarily individually, but as a whole? Because usually individual elements provide no value unless they're used with something else. So there's what we call a value chain. So various architecture elements, through their relationship to other things, will contribute value. As you go down the value chain, you end up producing some final value, which leads to the desired outcomes you defined before. So how are all these elements related? Partly how they're related in terms of value contribution, but also how they're related in terms of construction, in terms of build sequences and integration qualities, quality factors. And finally, how much cost is involved, because you can't, there's no point in having a perfect portfolio which you cannot afford. So these are the basic kinds of questions you need to ask when you're managing a portfolio. And the Unified Architecture Framework is well suited for helping you answer these kinds of questions. So within the UAF, you have some basic building blocks. And here you can see 4 layers. But there's 2 kinds of elements. There's the agents. These are the agents here. In other words, an agent is something that can do something. And then the agents are what give you behavior. So the thing we're used to is our systems, and in UAF we call that a kind of resource, but there's other kinds of resources such as technology, software, natural resources, human resources. All those resources can perform functions, and those functions are implementing operation activities. Those operation activities are performed by operational performers, and these operation activities trace to our capabilities. So it's the capability that will achieve desired effects or outcomes that are necessary for maximizing effectiveness and minimizing cost of your enterprise portfolio. So here is a portion of the ontology dealing with the front end. And there are some new elements that we've added at the beginning: driver challenge opportunity, which will be in version 1.2 of UAF next month. And we specifically added these elements because the way it was before, it didn't handle the front end of enterprise architecting that best supports the portfolio management process. Because the portfolio management need to know what the drivers are, what are the challenges, how are we going to address the challenges, what opportunities will we pursue. And that becomes the basis for the capability deployment plans that the enterprise will have. And we've also added effects and outcomes. We had actual states in there before, but there was no specific definition of effects and outcomes. So here's the conceptual schema. If you go down from the capability, you need to figure out what operation activities you need, what operation agents perform those activities. And that's happening right here. And I already mentioned operational performers, or one kind of operational agent. The basic idea here is that various resource elements are implementing operation elements. So everything over here, various kinds of resources, and you can see here that we have one of the kind of resources is a system. You also have capability configurations, you have resource mitigation, you have security enclaves, you have technology, natural resources, and even organizational resources are kinds of resource performers. So all these resource performers perform functions to implement operation activities. So everything on the right can implement something on the left. For example, a resource interface can implement an operational interface. A resource exchange can implement an operational exchange, and so on. So what are we doing when we're trying to map the drivers to those desired outcomes? Well, you're not going to figure it out in one hop. So you need to fill in the blanks starting with the drivers, recognizing what challenges that presents, what opportunities we need to pursue to address those challenges, what capabilities do we need to put in place. Now, every enterprise already has capabilities, so you look at your current capabilities and you identify capability gaps and shortfalls with respect to how well can I achieve the desired outcomes given the new drivers. And before we get to the outcomes, we have what we call effects. So there can be an effects chain, like a value chain. So think of value as one kind of effect. So many of our performance requirements we put on systems are directly related to some effect we're trying to achieve with that system. But it's effects that will lead to some kind of outcome for the enterprise. So if we lay down these new entities within the ontology, we can see we need to connect challenges to drivers, opportunities, challenges, capabilities, opportunities, and the effects drive our outcomes. So basically, if we put on the front end parts of the enterprise model, drivers, challenges, and opportunities to achieve those effects, this provides much better justification for new and improved capabilities within our enterprise portfolio. So I'm going to stop here and just for a second and see if there's any question I need to address in the chat window.
We have two particular questions. One from Gil Breyer.
Yeah,
how does one relate the UAF views?
So yeah, how does one relate UAF views to the system engineering requirements, functional, logical, and physical?
Yes.
Well, there are requirements objects. In fact, we use the system level requirement object exactly in the framework. And the functional, logical, physical, I think when I showed you this, let me go back here. When I go back to the ontology, you can see, and you may have asked the question before I showed you this. Here are the functions. Now, I don't show requirements. In the other ontology, there are requirements over here that can link to anything on this page. They can link to operation elements and function elements. And the logical is basically the operational blue element. That's your logical architecture. And your physical architecture is the orange. So in UAF, the operational architecture, which you can see here, think of that as the logical architecture. And this resource architecture, you can think of as the physical architecture. So what UAF domain relates to each of those views? Well, actually, you can have requirements apply to any domain. So let me go back to the domain so we know what we're talking about. So if you look at this, so each of these rows is a domain. You can have requirements in every single row. You can have strategic requirements, operational requirements, service requirements, personnel requirements, and so on. So of course, the logical architecture is the operational domain, and the physical architecture is personnel and resources domain. Okay, so that's how the domains relate back to the requirements, functional, logical, and physical. Does the architecture provide any method to capture risks of implementation? Yes, it does. And I didn't show that. I think I might show risk later. But every time you have an opportunity, in fact, let me check. I think I might have that on one of the conceptual diagrams. Let me just check. In fact, yeah, you can see it here. You can see risk. An opportunity you pursue can affect some risk, or maybe cause some risk to raise its ugly head. So that's how risk associated with opportunities, but you can also tie these risks to any of the resources, which I don't show it here, but think of it, there's also risk elements that can link to any of the operational elements and any of the resource elements. Okay, so I think that covers the questions, and Alex did provide some of the response to one of the questions. Okay, so we talked about what driver challenge opportunities do is provide better understanding of changes I need to make to the portfolio, and it can better convince the decision makers about the future path forward. And when you go to whoever's going to provide budget, it could be those decision makers, but in the case of government agencies, you have to go to Congress. So you have to convince people in Congress, congressional staffers, basically, that the money you're asking for is going to be good for the nation and good for the community and good for them. So when we're doing architecture, the architecture domains of UF, you can see on the right, those align with those don't align, but they're compatible with the architecting activities that you can see on the left. So this, don't mistake this to be a waterfall. This just shows there's a logical connectivity. So basically at the top, you have the most abstract things like strategy, and at the bottom, you have the most concrete things, in this case, actual resources. So in other words, these are layers of abstraction. And these are the kinds of information that you would see within each of the layers or domains, as we call it, in UAF. But when you're dealing with going from operational to the physical domain, that's where you do your analysis of alternatives and do your trade-offs. And you do trade-offs at each of the domain handoffs as you go down the layers of abstraction. And as I show in the middle, you're implementing operation elements with services, resources, standards, personnel, and security. And eventually at the bottom, you have actual resources that exist in the real world that you can perform verification, validation, and assessment of those implementations. So there's a standard workflow defined within the Enterprise Architecture Guide, consisting of these 9 steps. And it's purposely designed to be cyclical, because at the enterprise level, you always have a repeating business rhythm, whether it's quarterly, annual, or biannual. You have some sort of major cycle, but you can still have some minor cycles. You know, as things come up, a new driver might come up in the middle of the year. You may have to respond to that. So you might have some minor excursion through these steps. But in general, you tie this enterprise architecting workflow to the annual budget planning process, because every year you have to make adjustments to the budget. And this helps you lay the groundwork for justifying the request you're going to make to those who own the budget. So the major issue that you deal with when you're managing an enterprise is, how do you take those new and improved drivers and challenges and manage my portfolio? And the way you do that is by building out the architecture with these kind of architectural elements in steps 2 through 7. So using that workflow, you can have a much more systematic and early way of building up the information to justify changes to the portfolio. Now, of course, even though these are numbered steps, typically all these steps are going on simultaneously. And partly that's because you have different groups that are working on. You may have the operational people doing the operational architecture, step 3. You have your service engineers doing step 4. You have your system engineers doing step 5. You may have your business managers dealing with personnel architectures, your security engineers dealing with step 7. So it's often different groups of people, but the workflow keeps them all in sync and tied together, because underlying this workflow is the unified meta model, which if you model anything in any of these steps, then you can connect it to the proper things in the other steps in accordance with the ontology. So there's various uses of an enterprise architecture. We're focusing in this talk on portfolio management, but you can also do it for assessing your enterprise risk and opportunities, for assessing programs and projects, doing planning for the budget you need and executing the budget plans, formulating projects and planning those projects, and of course, defining requirements for systems. Of course, you're going to run into various challenges, because to build an enterprise architecture, you need information about the projects. Of course, projects don't like to give you their information because they're afraid what you might do with the information. It might tell you that they're not doing so well, or it may tell you that they're ahead of schedule, and they might say, "Oh, you're ahead of schedule. We need to borrow some budget so we can help this project over here that's behind schedule." So, and often that money is allocated to programs, so they have their own spending authority. So sometimes the enterprise decision makers don't actually have authority to tell the program managers what to do, because they don't have the authority. Program managers own their money, so to speak. So, and as we mentioned before, enterprise is different than a traditional system. It requires a different mindset, different knowledge and skills, different methods and tools. And it's easier just to incrementally change rather than doing, sometimes you need a radical change, and people don't want to do radical change. And no matter how good our crystal ball is, the future never arrives as we thought it would. I'm going to show you some example architecture views from UF that are in the search and rescue sample model that's part of the standard. So here's a capability roadmap for you can see the kinds of capabilities they need for improved search and rescue. Some of the operator performers that are involved in search and rescue. Now, if you want to see all these 100 views, you can download the UAF specification, and there is a document that has a search and rescue a UF view for every one of the views in the specification. So when you get out to the resource side, you need to what's the structure of the resources in terms of capability configuration, resource artifacts, systems, services, technologies, and so on. And then lay out all those resource elements on some sort of timeline. And sometimes we call that a system roadmap. And within UAF, we call that a resources roadmap. And eventually, you have to figure out what the projects are doing, because it's the projects that are usually building these resources, or maybe they're acquiring the resource, but then the project may need to tailor them, adapt them, or test them to make sure they're going to work. Now, be careful. You're not trying to use UAF to do your project schedules. You have to figure out which are the architecturally significant milestones for the various projects and programs within your enterprise. And those are the things you need to keep track of, because those are the milestones that deliver resources that eventually help you exhibit, as you can see up here. The milestones associated with resources that exhibit capabilities. That's what you care about at the enterprise level, delivering those capabilities. So you need to have a taxonomy. Yeah, I should say you need, but you would need to define your project taxonomy in terms of kinds of projects, define some sort of project structure. In this case, project milestone. It could also be projects, teams, and sub-teams. It also could be a composition of programs consist of these projects. These projects consist of these integrated product teams. And eventually you need to identify the architecturally significant milestones associated with those projects. And you can lay down these project timelines and map them to the capabilities. So the capability phasing view is one of the very important views you use for portfolio management, because it's really all about capabilities being delivered to achieve the desired effects. So as you can see here, we have two different versions of a landing vehicle. And the enterprise is some sort of Mars exploration enterprise. It may or may not be NASA. It could be the European Space Agency, or whatever enterprise is involved in exploring Mars. So you can see the program consists of two projects, and you can see when the capability gets delivered. You can also see the end of life of that capability. Now, it turned out that the landing vehicle has to carry the habitat down to the surface of the planet and be able to. So you obviously can't build the habitat capability unless you have the program that's going to develop the landing vehicle that's going to get up there. So the earliest you can possibly put the habitat capability in place is a function of when the landing vehicle version 1 will be available. And you can see that when the landing vehicle reaches end of life, then the habitat reaches some sort of end of life, because the landing vehicle needs to keep bringing supplies to that habitat. And once the supplies run out, then at some point with some delay, your habitat will no longer function. Now, it turns out they have an improved habitat increment number 2 that they have planned out. But according to landing vehicle version 2, which is a larger vehicle that can accommodate the larger habitat of greater mass and volume, we see a problem because it won't deliver that capability until after the habitat increment 1 has petered out. So we have a capability gap. So when you're looking at your current portfolios, you have to make projections in the future, project-wise and capability-wise. And it turns out the modeling tool will automatically calculate this gap. In fact, the capability phasing diagram is automatically generated with all the other information that it has in the model. So the project timelines, you need to pull that data from some sort of project timelines, from project schedules. But once you link up in the model your project deliveries for the milestone to the capability configurations, the capability roadmap shown here is automatically generated. So let's say I make some changes to my projects. So maybe I decide to spend more money to make this landing vehicle version 1 last longer. So I might need to give them some additional funding to improve the engineering and do some additional testing. That may be one solution. Or it may be that I give some more funding to landing vehicle version 2 project. And I tell them to don't use that fancy technology. It's not going to be ready in time. So I'm going to give you some requirements of relief so you can deliver the thing a year or so earlier. So there's various things you can change in your portfolio. And those are the various alternatives you're looking at when you're trying to manage the portfolio to close these gaps and minimize certain shortfalls. Let's say we adjusted the milestone of a landing vehicle 2, maybe requirement of relief, maybe additional funding. Maybe I need to move them into a new facility that's more modern so they can do their work faster. Or maybe I put in place a quality improvement program to make people more efficient and be able to do their work more quickly. So there's various things I can do to pull up that one milestone. But notice I closed the gap. So this is just one gap. In an enterprise, you might have 30, 40, 50 gaps that you have to deal with. And of course, as you move one thing around to close one gap, you might open up 3 other gaps. So it's really a very complex situation, which what part of what makes enterprise architecting so challenging because things are somewhat nonlinear in terms of their relationships. And it's not like building a watch where things are extremely linear. The watch may be complicated, but it's usually not very complex. An enterprise is complex versus large complicated watches. So when you're using the Unified Architecture Framework, the basic things you're looking at are what are the agents that are available to my enterprise, and what kind of behavior am I trying to achieve to address these challenges, opportunities, and drivers to achieve these effects. That's basically what you're trying to do when you're trying to rebalance the portfolio to become more effective and efficient from the enterprise perspective. So as we saw, enterprise is different in the sense we're not doing the typical input-output functional analysis like we do in a system. We need to do a different kind of analysis dealing with drivers and outcomes. And there are new methods and tools and techniques for doing that. But a lot of those tools and techniques are not in a typical system engineering toolbox. So one thing we system engineers need to do is to improve our toolbox. And one thing we can do is put in place the Unified Architecture Framework, which is specifically designed for dealing with drivers and outcomes and for helping support portfolio management. So that's the challenge, is how do we take system engineers who've worked 10, 20, 30 years on programs delivering successful systems? Can we move them up to the enterprise level? Well, we have to be careful because they're going to apply what they've learned over their decades of experience. So we have to train them. In fact, at the enterprise level, maybe we don't always need just engineers. Maybe we need business managers. Maybe we need operations people. Maybe we need people from customer support. Maybe we need people from the technology domains. Maybe we need people from the funding organization to participate in the enterprise challenges. So it requires a different mindset, which is also requires different knowledge and skills of the people. So the enterprise modeling ontology is basically the lingua franca. These are the entities and relationships that are available for when you use the UA framework and the underlying meta model. So we're basically trying to balance across the spectrum from the top, the strategic goals and objectives, all the way down to the actual resources that get built. The actual resources may not exactly conform to the definition of systems that we had up here. I mean, we had some idea of what the resources, in fact, we define our system requirements based upon our definition of those resources. And we have some notion of how the people will be involved, operators, users, maintainers, and so on. But all those predictions the engineers make don't always come about. So the bottom line is actual resources may not actually align with what we thought we were implementing. And that's why at enterprise level, you have to continuously monitor, looking for the weeds, looking for the weather, maybe provide, rotate your crops now and then, just like you're gardening. And it's just, you have to have a different mindset and different tools and methods. So the workflow is very important for helping you organize your work. In fact, think of this not as a process, but more as a work breakdown structure. These are the work elements that are needed to build various views in accordance with the standardized view specifications in the Unified Architecture Framework. And remember, our basic challenge is how do we understand these, what are the drivers and challenges, and how do I manage my portfolio to maximize effectiveness and minimize cost. And what I'm proposing here is that you can use the UAF framework with its ontology and language, and along with the guide that gives you a standardized workflow, to have a more systematic and effective modeling methodology that gives you more appropriate architecture views, especially for things like informing the decision makers that are trying to manage the portfolio. So as I mentioned before, we start off with identifying what those strategic drivers are. There's internal drivers, such as the enterprise executives have made some decisions about what their strategic plan is, what are their goals and objectives, but there's also external drivers dealing with the competition with the industry. We have the industrial base, we have the laws and regulations from Congress, from various national bodies. We have treaties and other obligations, many kinds of drivers, and these are a lot of the drivers that traditional system engineering doesn't even usually worry about. They don't even know about them, and usually they don't even care about them because they're usually given the requirements, and basically the system requirements are their drivers. But at the enterprise level, you usually don't have requirements that come in from the left. From these drivers, you identify your challenges, understand what effects and capabilities you're trying to achieve, and then manage your portfolio to address these challenges to give you these effects. So that's all I plan to cover. I'm going to check the chat window and see if there's any questions. I have a couple minutes left.
Yeah, James, there are several questions. We have a cutoff at 9, but I think one of the more important ones is the two related to the guide itself. So is it available for download, or when might that be available? But there are several other questions that we can get to as well.
Okay, so the guide is there's a pre-publication draft. I can send you a link to that. So my email address is on the title page. So if you send me an email, I can send you the link. In fact, if you really want to, I can send you the document itself. But next month it will be available on the official UAF webpage when they release it.
Great. Now there are several other questions you can get to however you please.
Is there a concept of use case like storytelling on operation level? Well, that's up to your methodology. That's exactly the kind of thing you would put in your modeling methodology. Are you going to use, let's say, the agile approach where you have epics and stories? Are you going to have the concept of operations document? There's nothing in UAF that prevents you from using stories like they do in agile. So, but you have to decide how you're going to do that. System level operational layer called conceptual. System layer is called logical. Yeah, there is some differences between the language that SysML uses and the language that UAF uses. UAF comes from a different legacy from DODAF and MODAF, from more of the enterprise architecting domain. SysML is more of a bottoms up from the project engineering, system engineering on projects, and it has kind of a different history. When they work on SysML version 2.0 will be out in a year or two. And as we go forward to UAF version 2.0, we're going to try to better align SysML and UAF. But that's just the terminology. Conceptually, there's much alignment between the two languages, and it was done that way on purpose. Stakeholders focus on their particular interest. Can you identify key stakeholders for each step on slide 32? Let me see what slide 32 says here. Slide 32. I'll answer the question. It says, yes, you can. It would not be possible in the guide for us to start identifying stakeholders, because the kind of stakeholders that apply would be different depending on your organization, depending on your culture, depends upon your domain, and so on. So yes, you can do that. In fact, in your methodology, you ought to identify some of the standard stakeholders that apply to each of these steps. Each UF domain can be a master model, so with each domain, I would not recommend that you put the different domains in different models. And there are practical difficulties. All the modern modeling tools can handle all these domains modeled in a single modeling project. There are models that have 2 or 3 or 4 million elements without any performance problem. So don't be afraid. I'm working on a enterprise model right now that has about 400,000 elements, and we're modeling all domains, and there's no performance problem at all. So if you're using Cameo, you have to use the features of the Teamwork Cloud to do proper branches and trunks and the evolution of your baselines. So in practice, I haven't seen large models be problematic unless you just didn't set the proper memory allocation on the server that you're running on. But that's usually just a matter of tweaking. Is the workflow model in the guide available for download? Not currently. OMG won't allow us to publish a model. They only want us to publish the specification. But we're trying to figure out some way to get the workflow model published. We may just have to put it on our LinkedIn page or our wiki page. But I can also send you the workflow model. It's currently modeled in Cameo if you would like to have it. Okay, so I think there's one more question. The question is, enterprise architecture, system architecture should be captured in separate model projects or commingled in the same model projects? It depends. If you're using UAF to model your system architecture, which you can, then it's okay to be in the same project. But you often have challenges trying to mix UAF models and SysML in the same project. It's better to have a separate SysML project and then use a project usage relationship between the SysML project and the UAF project. Therefore, your system level, you have available to you everything in the enterprise model that you can link to. Of course, it won't let you change it, but at least everything's available to link to, which is usually that's the common way you achieve that. So I think that's all the questions I have. So I'm going to let them take over the screen because I know they need to get ready for the next talk. So I will continue answering questions until I think I have about another minute left. So let me pull up the questions again.
Yeah, and you could always answer in the chat as well. But yeah, you might have 30 seconds to a minute.
Yeah, so the question is, are we doing stakeholders disservice by focusing so heavily on views and UAF? So that gets back to a methodology question. You have to design your methodology for the various stakeholders and figure out what views that some stakeholders can deal directly with the models, but in my experience, most stakeholders aren't modelers and they don't even understand how to read the model. So you need to figure out the proper way. In fact, you might have the same model, but different views for different stakeholders. that show different aspects of the same behavior, so to speak. So it's really up to you to figure out the best way to communicate to stakeholders, because stakeholder validation is very key.
Okay, and with that, James, thank you so much for presenting. We are going to be moving into our next presentation now. So James, if you'd like to answer questions, the chat is open for you. Additionally, we will have, if time allows, an additional Q&A at the end of this. Depending on engagement, we could extend this forum a little bit longer past our time in order to accommodate questions for both presenters. With that, our second presenter is Jodene Sasine. She has over 30 years of experience developing software systems for aerospace, automotive, and consumer goods industries. Her areas of expertise and interest are agile software methodologies, software model-based engineering, project management, and software development. Her experience spans a variety of domains, including aerospace systems, customer relationship management systems, connected vehicle technologies, product data management systems, enterprise data warehousing, and operations and demand planning systems. She joined the Aerospace Corporation El Segundo, California in 2017. In that time, she has supported multiple MilSatCom launch and other related programs. Ms. Sasine is a certified Scrum product owner, safe government practitioner, PMI certified project management professional, and has been a practitioner of agile methodology since 2002. Ms. Sasine received her BS in computer science and an MS in computer science from Loyola Marymount University, Los Angeles, California. Now, I'll pass it off to Jodene. Thank you so much for presenting.
Thank you, Alex. That was such a great intro and bio. I'm glad I wrote it. No, I'm just kidding. So first thing, before we get started, I like to take a moment, have everybody, if you haven't already, stand up, shake your arms and legs out, maybe take a sip of coffee, some orange juice, a glass of water, and then take a nice deep cleansing breath in and out. So that was a lot of great information that James just gave us on UAF. I'm going to take a different direction. So we're going to turn the corner and start talking about enterprise engineering analytics. But I did want to kind of give you that little moment to change gears, let's say. And I do apologize because I am a yoga instructor. So I like to open my classes with that kind of like stand up, shake it out, breathe deep, let's move on. On that, let's go to the next chart. Okay, so today's overview, this presentation I'm going to talk about today, we'll discuss the engineering analytics dashboards framework that the team that I'm a part of has been working on the last 2 years. This includes some specialized key performance indicators and metrics that we selected to support our framework or our initial framework. This also includes Agile and MBSE process assumptions to support the framework, which I will be going into detail on, as well as some proposed use cases reflective of Agile development and MBSE. We'll finish up on some insights on the challenges and lessons learned that we encountered or have encountered to date, and some brief summary and future direction on where we're headed with this framework. And then obviously question and answer at the end. Please put your questions in the chat, and I think I've left plenty of time to go over anything you might ask, as long as it's related to the presentation. Next chart, please. Okay, let's get started. Goals. So customers across the Department of Defense are adopting model-based engineering and agile software development practices that generate a wealth of engineering and management data. However, there's no current capability, based on our research, to look across this distributed data for a holistic enterprise view. So the engineering analytics dashboards, I'll just refer to them as dashboards for the rest of the presentation, will provide those who work on a program, such as architects, program managers, software engineers, chief engineers, etc., with knowledge at the right time to support integrated decision making. These dashboards will be built on a flexible framework with reusable templates and patterns that can be customized to a program based on their particular roles and data. The distributed data sources that we're looking at include MBSE models, Agile management tools, along with schedule and budget management data. The framework will pull this data into a business intelligence platform, for example, Tableau, to provide analytics and visualizations that are necessary to create these dashboards that can be used by the different roles within the program. Ultimately, our goals are to create holistic Agile enterprise knowledge, inform effective integrated decision-making, and highlight issues to reduce risk on the program. Let's go to the next chart. So the relationship between MBSE and Agile. MBSE and Agile development should not be independent of each other. Instead, they should help inform each other. The MBSE model is used to guide the Agile development effort, and the Agile development effort informs MBSE of any necessary deviations from the model that were required. This relationship is highlighted in the Scaled Agile Framework methodology, which you see on this chart. What we're showing here is the large solution configuration. So let's go to the next chart. So our fiscal year 21 dashboard scope. And when we talk about an enterprise, there are multiple levels to consider. The enterprise level is the broadest level that looks across all system of systems. And then the next level down is, of course, the system of system level. Finally, we get to the system level, which is what our initial focus is for identifying and developing our dashboards for this particular framework. Each of these levels, enterprise, system of systems, or system, has its own roles and use cases with differing perspectives and concerns. So the dashboards can potentially be applied at any of these levels, but they must be tailored based on the particular level. For our initial scope, we started identifying key performance indicators and metrics at the system level only, specific to a program. And those metrics included Agile metrics, systems engineering, and MBSE metrics solely. Future scope will address the system of system levels to see how the data can be aggregated there. And then finally, we'll move up to the enterprise. Let's go to the next chart.
It's time to do something about this stuff sitting back.
Do we have an open mic? Thank you. Okay, let's talk about the Agile focused dashboard. So let's skip to the next chart. Okay, so Agile considerations, process assumptions. Based on our research, there is no one Agile process that all programs utilize. And if you've ever seen the Agile Manifesto, you know it gives you guardrails, but there's room for interpretation. So based on this chart, there's a variety of choices in which Agile requirement hierarchy you use or follow for your program, which Agile tracking tool you use, how you implement Agile elements such as program increment planning, minimum viable product, or technical debt. So when a program is starting out with Agile, these are all things that as part of your methodology, and James talked a lot about the methodology with MBSE. So looking at how you're going to run your program agilely, these are questions that you should be asking very early on in the program, so that both the customer, the government, and your primes are all talking the same language with respect to Agile. So to develop these dashboards, we made the following assumptions. That we would use JIRA as our authoritative source of truth for our development data. This is the most commonly used tools, and there are other tools you can use. But for our initial focus, we use JIRA. And also as part of our initial focus, we assume the product increments, the minimum viable product, and technical debt are delineated within JIRA. Now, how they're delineated is obviously a customization for each program. In some cases, we've seen, if you're familiar with JIRA, there's labels that you can use. For program increments, you can use a release. These are all the things that we need to take into consideration when we customize a dashboard for a particular program. The key, though, for all of these metrics calculations is that we are using the authoritative source of truth for our calculation purposes. Let's go to the next chart. Okay. So Agile requirement hierarchy, again, talking about process assumptions, many different ways to, or different options for requirement hierarchy. And I've listed 4 here. These are the ones that we've seen across the multiple programs that the team has worked on. This is not all inclusive. There are many other permutations that you could implement. But most commonly, I think option A is what we've seen most commonly. And then even as I say that, I'm like changing my mind. But anyway, so a lot of this is governed. Some people typically will pick their Agile tracking tool, like in this case, JIRA, and they'll say, okay, JIRA has really good support for epics and user stories. So we're going to go with option C, and we're just going to use epics and user stories. And that's what we demoed, or that's what we built our dashboards on that I'm going to be showing you shortly. Other tools such as version 1 have capabilities that support features. So you could go with an option A or B. Anyway, this is one of those considerations that a program needs to determine upfront before they jump headlong into Agile development, because it's very hard to course correct as you're going through a program. So option C, specifically what we have from our test data is the epic to user story linkage. We do not have any mission threads in our dashboards at this point in time. And just a little background, a mission thread is an end-to-end thread that runs through the program or through the product. Very high level. So let's see, did I cover everything there? Yep. Let's go ahead and move to the next chart. Okay. So use case ideas for Agile, we came up with 3 of them. And they were defined based on the different perspectives of the different program office roles that we see in the government or working with our customer. So the first use case is focused on the material lead, or in some cases, the program manager, and the product manager is concerned for the minimum viable product that their program is providing to the end users for review and feedback. Now, there can be multiple MVPs for a program. So there's not just one and done MVP. You typically have more than one throughout the program. And in Agile, you want to give your MVP out to your end users for feedback, and then take that feedback in and adjust accordingly. Now, when I say give it out to the end users, I'm not saying it's in production. I'm not saying that at all. So the second use case is focused on the product manager and the release train engineer. So these are very safe-like terms, or scaled Agile framework terms, where they focus on program increment status, particularly the progress and the quality of the program increment for a particular program. Now, typically what we see is program increments run 3 months, but they could go 6 months. If you go 6 months, it's not very Agile, but typically what we're seeing is a quarterly program increment. And then the final use case is focused specifically for the release train engineer. And they're looking at the performance and health of the program's Agile development process, which is what a release train engineer does in the scaled Agile framework. They look at how the teams are performing, do they need to make any adjustments with the process, so on and so forth. So these are the 3 use case ideas that we came up with. And let's go to the next chart. what I'm going to talk about today is just particularly use case 1, which is monitoring MVP progress. So this dashboard is used to monitor overall program progress and quality of the work effort and understand risks associated with achieving excuse me, the particular MVP for timely user feedback. This dashboard is broken into 4 quadrants that represent progress, effort, quality, and impediments for a specific MVP. So this dashboard is focused on one minimum viable product. And as I've said earlier, this is requiring assumptions on what your Agile requirement hierarchy is and how you're identifying MVP, technical debt, and blockers. So in this case, we are following the epic to user story requirement hierarchy. And the other thing I want to make very clear is this dashboard is a mock-up. So the data you're seeing on this dashboard, on this chart right now, is not real. It doesn't correlate. It is more a visual, this is what we were thinking. And as we start to build it out, obviously the data becomes real. But what you see on this screen right now is I'll say, a figment of my imagination. So, you know, as you're reading across, progress and effort don't correlate. So just want to kind of put that in writing to start before I start getting questions in the chat about it. Okay, so let's talk about the top left quadrant, which is progress. So we're looking at the progress of a specific MVP, and it contains metrics that measure the amount of work that's been completed based on the total amount of work planned for the specific MVP that the dashboard reflects. And that's up here in the top left, and we call it MVP burnup. The second metric we're showing here is tracking the status of epics in story points. Now, I know this says epic/feature status. Again, this is a mock-up, so I would have fixed that had I noticed it before the presentation, but I didn't. So this would just be looking at epic status as applied to a particular MVP, which implies that your epics are linked to an MVP in your Agile tracking tool. So let's go over to the top right quadrant, which shows the level of effort identified for the particular MVP and the program's velocity in completing that effort. So on the left, you have metrics that tracks total story points of all the epics and enabler epics. So an enabler epic is like infrastructure, setting up a build pipeline, those kinds of things for a particular MVP. And here we're showing it by a program increment. So 1, 2, and 3. That was our going in position. We're going to show it by increment. And then the second metric over here is velocity. So program velocity is the amount of work. Usually it's done in story points, although you could use other things such as hours. Although I think story points are the way to go. If you're Agile, you go story points. But the velocity will show you how your teams are performing. You know, they committed to 50 points in a sprint and they only completed 25. So their velocity, 50%. Probably need to look at the process and see how we can make improvements on that for the next sprint or the next increment. So what you're seeing here is velocity for all the teams by increment, program increment. The intent of the bottom left quadrant is to modify quality of the MVP development and testing. So the metrics you see here, we have defect rate, which provides insight into the rate of growth or decline of defects over a time period. And it's really small, but you can't really see. We're showing right now problem reports, discrepancy reports, DRs, or CRs, which are change requests. And those are the different colors here. The second metric here provides insight into the level of testing that is integrated within the end-to-end development process. And additionally, the percentage of tests that are automated. The final quadrant, the bottom right, represents impediments in the development of a minimum viable product. So again, this heavily relies on the methodology, the software methodology, tracking technical debt and tracking blockers within their Agile tracking tool. If they're not tracking that information in Jira or whatever tracking tool they're using, then these metrics are not possible. Again, another process assumption we had to make. So technical debt is an indicator of what we had wanted to build, but we had to maybe back off from what we promised a little bit in order to get something done. That's typically, you put that in your backlog as we have to go back and improve something. That's technical debt. We eventually have to pay back that debt. And then the number of blockers is any work that's blocked. So we need an answer from the customer about, XYZ. We can't finish this work until we know that. So that's a blocker. Let's go to the next chart, please. Now let's talk about MBSE. Next chart, please. Again, everybody keep breathing in and out deeply. I know this is exciting stuff, but we'll get through it together. In order to develop dashboards for MBSE, we need to make some assumptions about how MBSE is going to be used on the program. So again, ad nauseum, there's a lot of process assumptions that need to be made in order to support this framework. And we need to be able to adjust and adjust our templates accordingly based on a particular program, etc., roles and use cases. So for MBSE, we assumed that MBSE is used to develop the architectural runway for the Agile development effort, which is very scaled Agile framework like, and it will be used to define epic designs for each of the program epics. As part of this process, the epics or features will be identified and traced to model elements within MBSE or within the model to capture which elements will be involved in the program increment. So this is where we start to get into thinking about linking an Agile tracking tool into a modeling tool, because perhaps our epics are the authoritative source of truth of our epic might be in Jira, for example, but we're going to link it into the model somehow. Or it might be the reverse, the epic is in the model and then Jira has to link into the model to get that epic information. Also, the subset of the model that is traced to the epic or features will be provided as a design or reference architecture for the Agile development process. After the completion of the program increment, we assume that the Agile development process will inform the MBSE process of any necessary deviations from the design or reference architecture so that the model can be updated to reflect the implementation. And so what we find with Agile when we're doing software development, and I've seen this on a couple programs I support, the model starts out with this is the to be, we pass it over, we link it into our development process, our developers go and ask questions, they build it, and then it comes back to MBSE or to the systems engineers to say, we had a discussion, we all agreed we needed to change this a little bit. So now your model becomes is updated and becomes the as-built. So there needs to be that handshake, close handshake between MBSE and Agile. Next chart, please. Moving along. There we go. Some more MBSE considerations. Accessing data. So accessing metric data from MBSE tools is not straightforward. And many of these tools offer means to access that model data, such as through model configuration management tools, example being Teamwork Cloud for Cameo, or through plugins that are built for the MBSE tool. Both approaches have pros and cons that are associated with them. Some of the MBSE tool environments do provide the capabilities either through the modeling tool itself, or as I said, the configuration management. They may provide APIs to access that information. We'll talk about some challenges with that at the end that we encountered. Also, some of these MBSE metrics, they can't be universally applied without any need for customization. across programs, such as, you know, the number of model elements, how many activity diagrams, how many sequence diagrams, etc. Now, if the methodology is not building any activity diagrams, then obviously this wouldn't work, but I think that's an edge case. Even after the model data can be accessed, there's still a number of challenges. And configuration management branching and baseline approach can vary between projects. So there isn't a standard way to determine if data should be pulled from a trunk in a model or from a particular branch. And we've been doing some work in that area. And we'll talk a little bit about that. It's still a challenge, and we're still working through some of the questions that we're encountering with that. Let's go to the next chart. Use case ideas for MBSE. So analogous to Agile, we looked at what are some ideas for MBSE use cases. And these are driven around the assumption of how MBSE will be used on the program. Again, back to the methodology, it's very important. We assume the model will be used to help define the scope and design for the program increment, as I previously mentioned. And therefore, we created a use case, excuse me, a use case called Monitor MBSE Model Development for PI Planning, where metrics about the model growth and traceability to the program increment can be monitored. The second use case is around tracking the progress of requirement satisfaction. Oh my God, that's a new word. In design. This use case tracks the progress of requirement satisfaction in the design for both Agile requirements and any other external requirements. Let's go to the next chart. So what I'm going to talk about in detail is the first use case, monitoring MBSE model development, which, as we just said, or as I just said, it's used to track overall model development and how well the PI epics and or features are satisfied by the design. So the top left quadrant contains metrics to monitor the overall growth of the model. The intent of these metrics is to see that the model is growing over time and how quickly that growth is occurring. The top right quadrant contains metrics to show how well the model is supporting the current program increment. It assumes tracing the PI Agile requirements into the design and having features or epics associated to the program, to that PI. Since the goals of the MBSE model is to define the design for that particular PI, by the end of the PI planning process, all the features or epics associated with it should be traced into the design. So that's the intent of that top right quadrant. The intent of the left bottom quadrant is to show and monitor MBSE model quality. And to capture model quality, there are several metrics used. Model checker metrics from MBSE tools can capture how well the model conforms to SysML syntax, for example. So these can be represented here. Ideally, there should be no errors. Another metric we can use for quality are model assurance levels, which Aerospace has done a lot of work in. And these represent the model's depth, breadth, and quality. They can be represented as a raw score or several scores over time to show growth. Finally, the bottom right quadrant shows the MBSE configuration management metrics. These can be used to monitor and ensure CM processes are followed. So in this example, we assume that the model would be version controlled after each program increment planning session. So versions are expected every 3 months. Therefore, the next expected baseline can be displayed and highlighted if it is missed. Again, back to having that clear process or methodology for your program, both for MBSE and Agile, so that we can get at these metrics. Counts of branches and merging can be used to ensure CM processes are followed, such as not allowing changes back to the trunk until the version is approved for baselining. Next chart, please. Metric customization. So as I think I've said ad nauseum throughout my talk here today, programs do things differently. So, and they need to, you know, depending on their particular subject matter area. So some of these MBSE metrics and dashboards, as well as the Agile ones, will need to be customized based on the program's modeling approach. And the examples that we're showing here in SysML illustrate two different but valid ways to model epics and features. So this example is assuming that we've got a requirement hierarchy that goes from an epic that then details into multiple features and then into, you know, epic, in this case, blocks for example 1. So example 1, we're using a requirement block for epic A and feature A. We're identifying those in the model as actual requirements. And then our system blocks, we link as a satisfy relationship to the requirement. And that's a very valid way of doing it. The second example, we are not using requirements for our epics and features. We're just using a block, or perhaps we've created the stereotype epic and feature. And then we are linking that into our system block using a trace relationship. Again, these are both valid ways of doing your traceability or implementing your traceability within a model. Our framework will have to be adjusted or customized to read either, you know, relationship or whichever relationship is being used in the model, so that we can pull out the metrics to support our dashboard. Let's go to the next chart. Where are we at with time? Oh, we got plenty of time.
Hi, Green. It's Steve Martin.
Hi, Mr. Martin.
Sorry.
That's okay. Let's talk about some challenges and lessons learned. Next, oh, look at you. You got it before I said it. Okay. I'm just going to talk off the cuff here, which some of you who know me, don't worry, I'll be good. Agile process. So the requirements hierarchy, I think I've beat that one to death. It's different across multiple programs. And you know, from an aerospace perspective, I've seen that highest level be mission threads that go down into epics and user stories. I've also seen capabilities at the high level based on like a capability description document, a CDD, which then breaks into epics and user stories. So it's just a matter of understanding for a particular program. When we're setting up this framework for a program, we need to understand the requirement hierarchy so we can adjust how we pull metrics. Also, processes need to be in place to be consistent for calculating, in our case, minimum viable product, technical debt, and blocker metrics. So this is an example of 3 metrics. There are other things as we go through the framework, as we get into more building out other dashboards, that we'll probably highlight that there are more process things we have to document. So along with our framework, we'll have to start putting together a process guide so that we can answer these questions up front and we know how to adjust accordingly. So from an MBSE process, queries for model metrics have to be customized based on a model's traceability, as I just spoke to you on the previous chart with requirements. Use cases, how is that being modeled? What are the relationships, so that we can access that information through backend, you know, processes such as Teamwork Cloud or APIs, etc. So the second one, to accurately compute modeling rule compliance, the selected validation suite will need to be customized to the model's content. So with Cameo, we have, you know, there's a lot of validation suites that come with Cameo. Or if we're doing the MALs, the model assurance levels, we will have to understand if there's any adjustments that need to be made so that when we run those validation suites on the model, we are getting the correct or accurate metrics. The final thing there is computing baseline metrics must be customized based on a model's configuration management schema. So as I said on the previous chart, how are, or when are changes being baselined back into, say, Teamwork Cloud, for example? Are they going to a branch? Are they going to the trunk? When do things move to the trunk? All of that is, we've encountered as we've gone through this, there's a lot of process that needs to be understood in order to have these dashboards generate effective information for the program stakeholders. Next chart, please. There we go. Okay, Cameo plugin and API limitations. So we're using Cameo. I don't know if I said that prior. I apologize. Cameo has been the most common with the customers that we've supported. So the Cameo documentation for their APIs currently lacks sufficient detail, and they are difficult to understand. We do look, we've pulled in a lot of user forums and so on and so forth, but it is a challenge that we have encountered as we've tried to access data within the model through the back end, let's say. It's also a bit difficult to access branch and version data in Teamwork Cloud. So a lot of this is more vendor specific that we're working through, and we're working with Dassault to understand how we can get at this information more readily and more easily. Also, navigating and querying model data is challenging due to model size, complexity, and diverse model organization. So some alternatives that we've been looking at recently, rather than trying to crawl the model data or via API access, we've been looking at could we create some generic tables in Cameo that pull in all this queried model data that we're looking for, and then we would just extract the generic tables. So that's one idea that we're playing with right now. So from a JIRA perspective, we may not have full access to the metrics that we need to create dashboards. And this kind of falls in line with the Agile process. For example, if they're not tracking technical debt in JIRA, well, then we have a harder time figuring out a technical debt metric. So on and so forth. And other things that come up with JIRA, well, and it's true with Cameo and any tool set, is where is the authoritative source of truth of the data? Does it is it residing behind a VPN with a prime contractor? How do we get there programmatically to access that information? Are we dealing with CSV files that are given to us, or model files that are shipped over from the prime? A lot of discussion in that area of how we access the authoritative source of truth for this stuff. Tableau, that's the last one we have here. Data has to be clean for Tableau to understand it. Because we are using Tableau as our initial framework, or as part of our initial framework, we are finding that there's some data cleanup that has to happen. And as you see there, small data sets. With small data sets, the views you can create in Tableau are limited, and we're continuing looking at how to expand that. Or perhaps it's just us not understanding completely Tableau, and I don't know, we need to go to training. That's entirely possible. Who knows? We're working on it. Let's go to the next chart. Okay. So to summarize, what I quickly went through today and was the KPIs and metrics that we selected to support our initial framework at the system level only, and that included Agile and MBSE, a lot of Agile and MBSE process assumptions, and I'm sure there's a lot more assumptions that we just haven't encountered yet, or we just haven't put into a presentation. We talked about the Agile and MBSE use cases that we developed for our framework. And I will point out, because at the beginning I did say we were going to address Agile, systems engineering, and MBSE. What we found out in our initial work, and one of our main systems engineers who was focusing on KPIs for systems engineering, She has since retired, but we ended up seeing that a lot of the SE metrics she identified were included in MBSE metrics that were also identified. So, excuse me. So we subsequently kind of dropped the SE independent KPIs and metrics because we found that they were covered already with MBSE when we were looking at MBSE KPIs and metrics. So that's why you haven't seen any typical SE metrics in our work. We just found that there, in our initial research, we didn't see any that were not already covered. And then I talked about some challenges and lessons learned in adopting, and adopting is probably not the right word here. It's more in building a framework and building dashboards for our programs. And I guess it would be adopting for the programs as well, because as we started to reach out to various programs within aerospace and start to talk about how their MBSE modeling methodology, what that is, and what their agile methodology is, there are some challenges with them adopting what we've done so far because it doesn't apply to them. So now we're starting to increase the reusability of our framework as we get more inputs from different programs within aerospace. So next steps, we're continuing to refine. We're not refining it, we're refining it and piloting what we've got so far in terms of our dashboards at the system level. And we've, like I said, we've met with a couple programs to date, and we're starting to work on that refinement. Providing guidance and support to our programs on system level dashboards. How do we help them adopt what we've been doing? And how do we adjust what we've been doing to be more meaningful to the programs? And then we'll continue our research, KPIs, metrics, dashboards, use cases for the system of systems level. And then eventually we'll get up to the enterprise level. Okay, next chart. All right, Q&A. So I've been not ignoring the chat because I don't ignore the chat, but I needed to stay focused. So let's see, are there questions in the chat?
Yeah, we got one or two. So one was about how you're linking JIRA with your MBSE modeling tool with Cameo.
Okay, good question. We have used Zendaya in the past for that linkage, and that is probably what we'll start with. At this point, we did not link the tools together, but that would be probably our initial attempt would be to use Zendaya. Right now, we are just accessing JIRA data independently and accessing MBSE Cameo data independently via APIs. So right now, on previous programs though, or current programs I'm supporting, they are using Zendaya to link MBSE modeling, well, particularly Cameo with JIRA.
Great. And we had another question, I think, buried in the discussion from the previous talk of, do you have definitions for enterprise, SOS, and systems? I think that goes back to one of your initial slides.
Oh, yeah. Yes, we do. And you're right. That's a good thing. I didn't really call that out in the deck. So let's see, off the cuff, the enterprise, if we think about, a portfolio enterprise level would be, if we're thinking customer, maybe the space, SSC or Space Force could be your enterprise. And then below that, a system of systems could be, I'm just going to go off the cuff, and if I may be saying this all wrong, so I apologize. System of system might be MilSatCom, and then within MilSatCom, you have a bunch of systems, whether it be, I don't know, GPS, or AEHF, or et cetera, et cetera. So that would be an example of enterprise system of systems levels and then a system level. I hope that answers the question. If not, feel free to email me.
This is James Martin. I have a slightly different notion of enterprise, no surprise.
Sure,
I don't
go ahead.
equate the enterprise with the organization. So saying U.S. Space Force is an enterprise, I think that's misleading. The enterprise is the human undertaking or venture where U.S. Space Force is a major participant. So the U.S. Space Force actually participates in several enterprises. I mean, there's warfighting support in terms of communication, providing communication to the battlefield. There's warfighter support with regard to overhead surveillance or reconnaissance. You know, there's various enterprises involved, and it has to do with some sort of venture. And even MILSATCOM, I wouldn't call that an enterprise. That's really a program area or capability area. So that's just kind of a different take on what an enterprise is.
Thanks, James. Thanks for the clarification. Let's see, what other questions?
Yeah, I don't know if you can see the chat. We have from Hans, have you considered using open services for lifecycle collaboration, which he links to, for the interface between the modeling tool and the dashboard tool?
Actually, yes, we have. We have not implemented any of that, but we're looking at how do we utilize OSLC. Thanks for the reminder, Hans, because that was some work that I did probably a year and a half ago on OSLC, and I honestly had slipped my mind. So we need to revisit that.
Yeah, and that may have been a two-parter of could OSLC be the kind of standardized REST API that we need to enable collaboration? I don't know if you answered that.
Oh, I didn't. I'm sorry. That's a good question. I don't know. I can't really answer that. Just because it seems like it would be, but it's been a while since I've been developing code, a long time actually. So I probably would leave it to my developers to say, yeah, this looks pretty good to be standardized. But I think that was the intent that Cameo was going for, that it becomes that. So that's my 2 cents. Let's see, what metrics are you using to evaluate model maturity? Let's see, well, let me go back to that chart. Could we flip back to chart, let's see which one it is. I think it's chart 15, please. Yeah. Okay. So let me move the chat window so I can see. So for model maturity and what we've got here, and Dr. Julie Font did a lot of this MBSE work, so I'm probably going to flub it. And if she's on the call, feel free, Julie, to chime in. So what we've looked at for model maturity, we obviously are doing a lot of work with model assurance, or I'm sorry, MALs, the model assurance levels, which is work that Dr. Julie Font has been spearheading at Aerospace to look at the, different levels of, thank you, Alex. So this was presented last year, and I did remember that now. Because, I honestly am going to flub this. So what you see here is we were looking at, we don't have the details of the MAL data, which I can't really read because it's too small. So I apologize, Lauren, I can't really answer your question specifically. However, Alex, yeah, it's that area. Oh, thank you. Okay. So the MAL is built to assess requirements content, structural content, behavioral content in those areas that you see listed there. Unfortunately, I cannot give you the details of the validation rules that the MAL is running in order to speak to, what does it mean? What does maturity mean with respect to requirements content? That is Dr. Font's area, and I know it's near and dear to her heart. But if I could just point you to the link that was provided in the chat, and if you have follow-up questions, you can email me directly and I can put you in touch with Dr. Font to talk about that in more detail. And Alex, if you could just throw my email into the chat, that would be great, because I don't think it's on the presentation. Pretty sure I didn't put it on there. Okay.
Any other questions for Jodene here?
Yeah. Oh, thank you, Alex. Any other questions? I can talk your ear off about Agile, but this is a systems engineering forum, so you probably don't care too much about that. But anyway, if you have any Agile questions, let me know. I thank you for your time today. And on that, I'll hand it back to Alex and wish everybody a great rest of your day. And go ahead and go make your dreams come true.
Thank you so much, Jodene. I'll pass it back to Alex Chang to close us out here.
Thank you. Thank you again to both of our presenters. I just have a few closing slides, so if we can go to the next one. So thank you again, James and Jodene, and all of our event administrators for bringing this all together. Following this event, you can expect three things. First, a PDF of the presentations will be made available for download on the SCF archive site. A few of the resources that were presented in chat, as well as that were talked about, will be added as additional references within that archive site as well. So keep an eye out for that. Secondly, our recording of these events will be made available on the Aerospace Corporation YouTube channel and additionally linked on the SCF archive site. So again, keep an eye out on the archive site. And third, a quick question survey, doesn't take more than 3 minutes, will be provided to attendees to garner some feedback. Any feedback is absolutely appreciated, so please let us know what we did. It helps us to inform what new presentations we'd like to, that the community would like to know about, would be interested in, and so forth. So next slide, please. If you have not done so already, please register for upcoming events. Our next event is themed Agility in Acquisitions in April with Agile V&V and DE Workflow. With that, thank you for attending. That concludes the first event of the 2022 System Engineering Forum. We wish everyone a wonderful day. If you'd like to stay online and you have a few more questions, we will be unmuting the audience now. So if you'd like to post more questions in the chat for either of our presenters, you are welcome to do so. Depending on activity, we'll be closing out between 10 a.m. Pacific or sometime a little bit later on. But thank you.